synthesis problem.
Is that the only source of carbon?
Yep. Two synthesis problems. So you can assume that the chemistry stockroom has a standard set of inorganic reagents, and that the local grocery store has dry ice. Always helpful to map out your carbon atoms. Pretty easy in the right one, isn't it, to map out your carbon atoms? Six-membered ring, six-membered ring, six-membered ring. Three-carbon chain, three-carbon chain. How about over here?
The methyl on this one's methyl on the right.
Okay, so this methyl 1 is this methyl 1.
And then
2, 3, okay. This is the only starting material you get for carbons.
Yeah, I'm doing 3 carbon chain now.
1, 2, 3. So you're going to use that one twice. Okay. All right, so a good idea is to analyze what you got in terms of functional groups. Alkynes. Oh, really? That's old stuff. Really? Yeah. How about in the product? Anything look familiar from before? What's going to happen to carbons 2 and 3?
You
You have to reduce it, right? How do you make a transalkene? Remember, you're going to have a reagent sheet, so you don't have to always hold on to the memory of what the reagents are, but it was... Lindlar's does a syn addition. It was lithium and ammonia. Lithium metal and ammonia. So I could add a pair of hydrogens anti using lithium and ammonia. Okay. Any ideas what we could do here? Yeah.
So lithium and ammonia won't reduce the alkyne all the way?
No, it stops at an alkene and makes the transalkene. So could you back up one step and say carbon-carbon triple bonds? Thinking backwards. Last step, lithium, metal, and ammonia. No? Yes. What do you think next? What kind of a bond do you have to make? Carbon-carbon bond. Do we have any reagents for this unit that are good at making carbon-carbon bonds? Organometallics are great at making carbon-carbon bonds. So who is the organometallic? We need to make this bond, don't we? Who is the organometallic?
Carbon, copper.
I don't know. Big hint here. So what was the left-hand side of the molecule? How did it look before it became that?
Was it a carbonyl?
Had a carbonyl group. And what was attached to that carbonyl group?
Carbon chain, or the R's. Two methyls.
Two methyl groups. And what did it react with?
Was the lithium?
Yeah, the right side of the molecule would have been our organometallic. Have we seen that one before? Does it look familiar at all? Called that the acetylide anion, didn't we? It's an example of an organometallic. How do you make that from this? NaH, a strong base. NaNH2, NaH, either one. How do you make the top molecule? Yep, water, mercuric sulfate, H2SO4. Oxymercuration. Reagents would be on your reagent sheet. If you forget what they were, you can always reference it. It'll be on the reagent sheet.
So these were all on the reagent sheet besides the lithium NH3, right? Or
Actually, everything here would be on your reagent sheet. It's all old reactions, isn't it? Pretty much. We just, in the old reactions, we never saw this reacting with a ketone. That's in our new material, is that ketones will react with organolithium reagents or organomagnesium reagents, Grignard reagents. Is that okay? That was kind of a straightforward synthesis, I would say. Michael?
Between the cell, acetone, like between those two, one carbon, would you need?
So this adds water to make the enol, and then the enol is in equilibrium with the ketone. So this is a one-step synthesis of the ketone. Is that all right?
Yeah,
What did we use, what reagents did we use to put them together?
They just, this is a nucleophile, this is an electrophile, they just react. That's the chapter on organometallic chemistry. Carbonyl compounds are electron poor, electrophiles. Organolithium reagents are good nucleophiles. Michael?
I guess for going back to that, the second, wouldn't you need for a second step to add acid to propane?
Yeah, we really would. We'd probably, first of all, react them together in a solvent, and then we would add some acid to it. It would protonate the oxygen. I wouldn't take off points if you forgot to protonate. That'd be full points like I forgot it. All right, so there's one. How about this one over here?